Hi, anyone there? Okay, still no one here. All right, okay. Let's wait and see. Oh, okay. So the two of you say hi. Hello. Okay, we wait for a while. Yeah. Okay, let me get on with the attendance first. Oh, hello, Razin. You are always the first one to be here. Good for you. Okay, let me adjust my necklace. Hello, Damir. All right. Okay. Good morning, Faris Adam. Okay. Good morning. All three of you are here. Okay. Let me give you the attendance. Yeah. There you are, the attendance for today. All right. Okay, guys. I'm not going to waste much time because I have to go to the PM version class later at 8:30. So we just get on with whomever here. Hello, Amir. Whomever here, we just get on with that. Okay. One thing that I noticed that because yesterday night I was like really busy, I forgot to mention this in the Google Classroom. All right. If at all you have any of your friends who are not in the group, please let them know. All right. It's actually my bad. My bad. All right. Okay. My bad. Okay. Yeah, it's a bit hot in here. Okay. Hi. Okay. So yeah. So I'm going to share screen now. All right. Science form 3. Yeah, okay. So the other day, okay, last week we didn't have any class because I was quite busy with the bio examination and all that. All right, so today we are going to go straight into movement and exchange of gases in the human body. Okay, so previously what we saw is the breathing mechanism. All right, we saw the breathing mechanism here just to refresh your memory lah, right? Just to refresh your memory. So we had this breathing mechanism where how the intercostal muscle and the diaphragm, the intercostal muscle and the diaphragm work together in order to, right? Okay, kejap. Let me, right. Okay, can you see the, all right? Okay, sorry. Okay, so this was our last lesson. All right, the mechanism of breathing, inhalation and exhalation. Okay, guys, one thing that you need to remember is when you're dealing with the inhalation and exhalation, you are dealing with the pressure and the volume. Okay, what you need to control is the pressure and the volume, which is taken care of by your intercostal muscles. All right, so the intercostal muscles are the one and the diaphragm together. So they are the one who control the volume in the thoracic cavity. We call this as the thoracic cavity, the rib cage. All right. So when the volume is fluctuating or it's it has changed. So obviously your pressure is going to change. So when the pressure changes, automatically the air either comes in or goes out. So you have to be careful of that. All right. So this was what we learned. Easy to scroll down. Okay, no, I don't think so. All right. It's a bit slow, in here. Dia pergi health pula. Okay. So today what we are going to see is how the gases are going to be exchanged. It's going to be pretty interesting here to see here. All right. So we are going to see the gaseous exchange of oxygen and carbon dioxide in the human body. All right. So what is the respiratory surface? All right. What do you understand if I tell you what is the respiratory surface of human? What is the respiratory surface? What is the meaning of respiratory surface? Anyone? Respiratory surface. Apa itu? Sort of coffee, you know. Lungs. Okay. Lungs is the organ. Lungs is the organ. It's not the respiratory surface. Mandrani, good morning. You came itself straight away jawab soalan, eh? All right. Lungs is the organ, dear. All right. Because this type of question always comes out. They ask you what is the respiratory surface, and you cannot be saying it's the lungs. Who can answer? What is the respiratory surface of human? Respiratory surface. Just listen to my question carefully. Respiratory surface. I'm already showing you the picture. Oh my God, I'm giving you clue all. I'm already showing you the picture. The respiratory surface picture. Siapa boleh jawab? Alveolus, yes. Okay, so this is our respiratory surface. What? No, Mandrani, it's not bronchial. Okay, why we call it as the respiratory surface is because this is where the gaseous exchange occur. All right, so that is why we call them as the respiratory surface. In Malay, you say pertukaran gas. This is where it happens. Okay, so that is why we call this as the respiratory surface. Right? Okay. So back to this one. All right. Okay. So okay. How have you ever wondered about the process of movement of particles such as oxygen and carbon dioxide from an area of high concentration to lower concentration? So what is this process? Okay, let's answer this. What is this process? What is the process of the gas molecules going from high concentration to low concentration? Guys, these are your exam questions. The apple don't fall far from the tree, you know. Actually, that is for inheritance. But then, you know, when they ask you what is the process of gases moving from high concentration to low concentration, what is it? See who can answer. There are only 7 of you here today. You know, the attendance is actually fluctuating, you know. I should actually form a group with your parents, actually. Then only you all could. Okay. What is the process of movement of gas from high concentration to low concentration? Let's see who boleh jawab. No answer? No answer yet? Inhalation, no. The process is simple diffusion. Take note. All right, I type here. Simple diffusion. Diffusion. Okay, so this is the process. Now they're asking you the process. Right, inhalation and exhalation are breathing mechanism. Right. So I know it's quite confusing. Oh, why? So many words. Yes, bio is like that. All right, but now we are not learning bio, we are learning science. But basically, the idea is the same. You need to know a lot of words. All right. Okay. So when a gaseous molecule is going from high concentration to low concentration, we call this as simple diffusion. So the gas diffused from a low concentration of high concentration in the alveolus, oxygen, it will diffuse into the low concentration in the blood capillary. So same goes to your carbon dioxide. Carbon dioxide is also the same. Carbon dioxide is from high concentration, which is in the blood capillary, and they will diffuse into your alveolus, where you have the lower concentration. All right. So that is what you need to understand here. All right. Okay. So you see, okay, this picture is actually, it's a beautiful picture, which is showing the movement of diffusion. I don't want to use the word movement. Actually, by right, we should be using the word diffusion. All right. Okay. So when you see, okay, you have to start somewhere. When you are looking at the picture or diagram, you have to start somewhere in order to understand it. All right. So if you see here, the blood that enters, okay, this is your capillary. All right. This is your capillary. All right. So this part here is the capillary, and they are all one cell thick. If you notice, all right. If you notice, they are all one cell thick. All right. And so is your alveolus. Your alveolus is one cell thick, and also your blood capillary is also one cell thick. Okay. Why are they one cell thick? Anyone can answer me. Why do you think the blood capillary, all right, why do you think the blood capillary and also your blood capillary and your alveolus is one cell thick? Let me see who can answer that question. Our necklace looks really nice today. All these no weddings, just wear for class. Hilarious, lovey. What is it? Why are the blood capillary and your alveolus are one cell thick? Okay, who can answer? Can't wait to see you guys, on the 5th. Siapa boleh jawab? Why are they one cell thing? It's actually pure logic, There's no magic behind it. Why? Why are they one cell thing? Ting, ting, ting. There are 10 of you here watching. I don't know who are those. All right. Cepat. Why are they one cell thing? The blood capillary and as well as the alveolus itu, why are they one cell thing? Alamak. Nobody wants to answer. Ame, Raisa? What is it? At least one answer. Someone answer. Yeah. Each of the style, energy, no. Razin Azaha, no, not because of that. Okay. This one is a bit near, but it's not that accurate. All right. Okay. To allow the molecules to diffuse, the word there must be easily. You must have the word. It must be easily. It must easy to diffuse. Okay? Itu sebabnya. So, why are they one cell thick? Is so that they can diffuse easily. They can diffuse faster. Like you take a piece of paper. Okay, I have a piece of paper here. All right? It just say I poured coffee on it. No, coffee is for drinking, If I pour coffee on it. Okay, then I have another one. I have the book. All right? Okay, so which one do you think the coffee will, and I pour on coffee on both of them, which one do you think it will diffuse faster? The coffee will diffuse down faster. Which one? Which one do you think it will diffuse faster? Which one do you think will diffuse faster? If I pour coffee, all right, on both, all right, which one do you think the coffee will diffuse down here faster? Paper. Very good, Mandrani. Simple. Logic only. Right. Logic saja. Why? Because it's thinner. All right, compared to the book. So that is it. So that is why, because the main function of your respiratory surface is to gaseous diffusion. Right. So of course they have to be thin. so that your gaseous diffusion is faster. Zoop, zap, zoop, zap, zoop, zap, zoop, zap. Isn't it? So that is the idea. All right. Okay. So that is why they all must be one cell thing. Okay. The blood that enters here, all right, it has a lower concentration of oxygen and higher concentration of carbon dioxide. Okay. Why is this? Is because this blood that enters here, this side in it, it actually has a product of respiration, because it's coming from the cells. The cells has finished their respiration, the cellular respiration. So they have taken in, utilized all the oxygen. All right, not all, some of it. So they have utilized the oxygen and they have given out a lot of carbon dioxide. So all that will be brought into the alveolus by your blood capillaries, through your blood capillaries. Okay, so once they reach here, all right, so the diffusion happens according to the concentration gradient. Right? So here what happens is the carbon dioxide in the blood capillary is higher compared to the alveolus. All right? Your blood, in the blood capillary, the carbon dioxide concentration is higher compared to the in the alveolus. Thus, the carbon dioxide will diffuse from the blood capillary into the alveolus. Alright, so this is how it goes. That's why we call it a simple diffusion. Simple diffusion will always occur from high concentration to low concentration. That is the law. So carbon dioxide is high in the blood capillary, but it's low in the alveolus. So thus they diffuse into the alveolus. Alright, okay. Then the oxygen. Oxygen, you are depleted in the blood that comes to the alveolus. The oxygen is depleted. Okay, because you have used all the oxygen, not all, that's lie. All right, so you have utilized the oxygen for your cellular respiration. You utilize the oxygen in order to get energy in the cells. So now you are lack of oxygen, but the oxygen in the alveolus is higher compared to your blood capillary. Thus, it moves from the oxygen from the alveolus, it diffuses into your blood capillary. As simple as that. All right. Okay. Again, the blood that enters into the blood capillary. Okay. Blood that enters into the blood capillary has higher concentration of carbon dioxide. Why? Because carbon dioxide is the product of your respiration. So it diffuses from the blood capillary into the alveolus. All right, done. Okay, your oxygen has been depleted in the blood capillary. It's very less. Why? Is because they have utilized the oxygen in the cellular respiration. So the oxygen in the alveolus, you have higher amount in the alveolus compared to your blood capillary. So it diffuses from the alveolus into the blood capillary. Right? That is it. Okay. Okay, so that is what happens. Okay, you need to understand this, because you see, guys, this type of question always comes out for your structure questions, and you must be able to explain this properly. Okay, so in order to do that, you have to understand why is it like that. So that is the main idea here, lah. All right, okay. So moving on, you see. So the blood with higher concentration of oxygen and lower concentration of carbon dioxide will go into your cells. The capillary will bring it, they will go into the larger vessels, and the artery will bring it, and then after that they will somehow or other they will reach the cells. So in the cells, the exchange is different. Now the blood has a lot of oxygen compared to your cells, because in the cells your oxygen is less because they are utilizing the oxygen. So the oxygen from the blood capillary will diffuse into your cells. Alright, whereas your carbon dioxide is higher in the cells compared to your blood capillary now. So the carbon dioxide will diffuse into your blood capillary. So it's the direction here, it changes depending on their concentration. In the alveolus, from the alveolus, carbon dioxide diffuse into the blood capillary, and from the blood capillary in the alveolus, the carbon dioxide will diffuse into your alveolus. But when you are going to the cells, you are in the cell level, the carbon dioxide in the cells will diffuse into the blood capillary, while the oxygen in the blood capillary will diffuse into the cells. So this is what happens. All right. Okay. So far, any question, guys? So far, any questions? You all okay? Okay, dokie. Okay, dokie. Man, okay, dokie. All right. Okay. So still there are only 10 of you here. I don't know. Maybe it's my fault because I forgot to put it in the Google Classroom there. Please, those who still, I don't see the usual people that I see it here. Okay, but never mind. But I still submit whomever here. That's the attendance that I'm going to submit. All right. I'm so sorry. I was really busy yesterday, and I forgot. Not to say forgot. Macam cycle, yeah. It is actually a cycle, but then what diffuses where depends on the concentration. All right. If the concentration of the gas is higher that side, then it will diffuse. It depends. Dear, that's the thing. It will diffuse from higher to lower. That's it. All right, as easy as that. So they will diffuse from higher to lower. That's it. So that is how it goes. Okay. All right. So, but you need to understand why it's higher there. Why is it lower there? That's a very common question you're going to get. Right. Okay. Moving on. There. This is what you need to read and understand. All right. Okay. Let me hide that. Okay. I make it a bit that smaller. Okay. So number one, the air inhaled in the alveolus has a higher concentration of oxygen compared to the concentration in the blood. Of course, because the oxygen has been utilized. It's coming from the cells. The cells have nicely used all the oxygen now. You have no oxygen. I mean, lack of oxygen in the blood. So therefore, the oxygen will diffuse from the alveolus into the blood capillary. Right? Okay, this is important. In the red blood cell, there's a dark red color compound known as hemoglobin. It's actually a protein compound. So this hemoglobin will combine with oxygen to form oxyhemoglobin. Oxyhemoglobin is a compound which is rich with oxygen. Okay, so we have like an iron, like a ham group, which is like it is actually the base of this is iron and protein. So what will happen is they are very, very receptive. They are very, very receptive to oxygen. So whenever they see high oxygen, they will want to bind with them. All right, which is an unstable compound. But then it's quite unstable. Why? Is because if you're too stable, you won't be able to get rid of the oxygen when you need it. So it is a bond, but it's not that stable. All right. So oxygen plus carbon dioxide, you will get oxyhemoglobin. All right. Then the blood with oxyhemoglobin means it's a blood rich with oxygen. It will go transported from the lungs to the heart. Of course, your heart will pump again, right? Because the blood enters the heart twice. It will pump again. It will go into the aorta and it will reach to all parts of the body. So when the blood reaches the area around the body, it has a low concentration of oxygen. Of course, the cells are using the oxygen for their cellular respiration. So since your oxyhemoglobin is an unstable compound, all right, so what they will do is they will decompose them. What they mean by decompose is not like rotting away, because the students will say rotting. No, decomposition means it's a place where they will release their oxygen. Okay, they will unbind the oxyhemoglobin from the oxygen and the oxygen will diffuse into the cells. Okay, now you have hemoglobin again. So that is why the bond has to be unstable. Okay, so the bond has to be unstable. Then after that, they will diffuse into the body cells. The body cells, they will utilize the oxygen, they will do the cellular respiration, and they will give out a lot of carbon dioxide. All right, so the carbon dioxide will be diffusing into the blood capillary, and the blood capillary will bring it into your alveolus. So when they bring it into the alveolus, the carbon dioxide will be released by the cells, diffuse into the blood capillary and transported to the alveolus to be removed during exhalation. All right. So this is what happened. Okay, guys. So far, so good. Any questions? All right. Okay. Does the oxygen being absorbed by the red blood cell? Yes, Amir. They do. Yes, they do. All right. They do. What they will do is they will absorb the oxygen because their lack of, you see, the concept is very simple. It is simple diffusion. So when you're dealing with simple diffusion, what happens is wherever the oxygen is higher, they will diffuse into the place where it's lower. So wherever the carbon dioxide is higher, they will diffuse into the place which is lower. That's it. Okay. So, but then yes, they do have a transporter. All right. Yes, the transporter. Yes, this is the transporter, the hemoglobin. Yeah. All right. So the hemoglobin is a substance which is actively, it's a unstable compound. I don't want to use two different words. I don't want to confuse you further. So in your book they use the word unstable compound. So I stick to that. So it's an unstable compound. So they bring it everywhere, every other organs, every part of the body. So what will happen is wherever the oxygen is less, they will just unbind and they will diffuse into the cells according to your concentration gradient. That is how it works. Okay, everything is according to the concentration gradient. Right? Okay, thank you, Mandrani. You had a very good question today. All right. Okay. So yeah, the importance of adaptation. Okay, guys, when you, like I said, in biology, all right, in biology or whatever, in science basically, all right, biology la, science I don't know, physical and chemistry all I do. But if it's a structure which is like going to do a certain function, okay, if there is a structure which is doing like a certain function, they have to have a certain adaptation. Adaptation means what are the modification done to that particular structure in order for them to bring in the in order for them to carry on their function. Okay, that means like, oh, if I'm a teacher, I must have this few qualification in order for me to teach. That's my adaptation. So the same goes with the cellular, the structure here. All right. So they must undergo some adaptation. Maybe they have to look very much different compared to the other type of common cells or common tissues. All right. Why is because they have beautifully adapted to perform their function. So they have beautifully adapted to perform their function. So that is the idea. So every type of respiratory surface, especially the one that they are concentrating in your syllabus, is an alveolar structure. So they must have certain characteristics. So they must have these certain characteristics in order for them to carry out their function. Okay, in order for them to carry out their function. All right. So what they need to have is, number one is the thickness. So that is why they must made out of one layer. They cannot be like this. Alright, they have to be one layer. Okay, so why? Because it facilitates the movement. It increases the rate of diffusion. So that zoop zap, gas, oxygen and carbon dioxide, zoop zap, they can go here and there. Right? Okay. And they must have moist walls. They must have moist walls. Okay. Why is because, okay, you may ask teacher, moist walls, where? Okay, I show you. Can you see this part here where there is a small gap between the alveolus and the blood capillary? This part here is actually filled with fluid. All right. We have some fluid there, where the gases oxygen and carbon dioxide will dissolve and diffuse. Alright, so this is where, okay, so they are moist at that place. So when they are moist, the gas can dissolve, then they can diffuse. Alright, they dissolve first, then they diffuse. Okay, so once they diffuse, that's it. This is one of the adaptation that they have. Alright, okay, what is the fourth one, third one? Surface area. Oh my. The number of alveolus, they are like a bunch of grapes. Okay? They are like a bunch of grapes. I don't know how to say it. They say like a bunch of grapes. Why they are like that is because they want to increase the surface. Compared to, I don't have anything. I should have brought if my husband buy grapes, I don't think so. Have to find something that has a higher total surface area. So even it's all like they are small, strong structure like that, they have a higher surface area. So when you have a higher surface area, there's more diffusion of the gases. So that is the idea, right? So rather than a flat structure, so when you are in the small, like you are folded or you are in a grapes form or something like that, what will happen is the diffusion is more because your surface area is more. Right? Okay, then you also, they are rich with blood capillaries. That is one reason, guys. You may be wondering why the COVID is like, why is it like spreading so fast? Why is it like, it's like, it's like so hard. Because you see, it affects your respiratory, the respiration part. And in the respiration, what is the most, okay, of course, the virus doesn't do that. But, it's actually not to say COVID, not to say COVID, because I cannot relate the COVID to that. But the invasion here, it's like very good. Why is because I cannot use the oxygen because your virus have no metabolism to work with. It's actually the blood capillaries. The blood capillaries, you have so much of blood capillaries there that they spread really fast. That is what. Any type of disease which is like respiratory related, they spread super fast. Super fast. Why? Because number one, if it's a bacteria, it's even better. Why? Because they have abundance of oxygen there. It's like a playground for them. All right. And you have beautiful highway, which we call it the network capillary. So they have oxygen. Oh my God, so much of oxygen, like this mad candy already. And they have like, oh my God, I also can travel everywhere, anywhere I want. No passport needed. So they go everywhere and they spread the disease. So that is the idea. All right. But why actually God gave this to us is because they want to make sure increase the diffusion of the gases and increase the efficiency. But it also becomes very, very advantageous to some organisms, especially microorganisms. It's a tough place to deal with. Okay, that is why, like some people, like my dad had lung cancer. All right, so the spreading is like super fast. It's like zoop zoop zoop. Why is it spreading really fast? Is because of the place that he contracted it. All right, the place we got it was the lungs, and lungs are rich with oxygen, rich with blood capillary. Right, so it spreads. Right, so that's one thing you have to remember. So when you are dealing with like microorganisms and so on, lung is a beautiful place to live. It's like heaven. A lot of oxygen to work with, a lot of blood capillary to work with. You want what type of nutrient? Everything is there. Right, so be careful. Be careful. I remember, I have to say, the other day was a Tamil paper, YouTube or no YouTube, let me tell you this story. The other day we had Tamil SPM paper. Teacher took Tamil until SPM, teacher I took Tamil until SPM. So I teringat masa saya duduk SPM tau. We had one teacher. This teacher ini, of course, he speaks in Tamil lah, kan? He speaks in Tamil. But then these are the memories. When you all go out of the school, you will be remembering this type of stuffs. I hope you remember me lah. And if you anytime you want to see me, my YouTube is there. You can go and see me. All right. This teacher is like very stern teacher, but he's really funny. Is his own way. Okay, so he will be always like what, he will say in Tamil lah, you shouldn't do like this, his face will be like so like, in those days, guys, it's very hard to find laughing, smiling teacher like me. Honestly, all the teachers are like, this is a standard face. I don't remember a teacher who always smiles. I never had one in my history. Either they are stern looking or they have neutral face. At least the neutral face is acceptable. So I decided when I become a teacher, I decided I don't want to become a neutral face and I don't want to become a stern face. So I keep on smiling. Right. Okay. So back to the teacher's article. He always will like whenever we make a mistake. I mean, not only me, when any of my classmates makes any mistake, he will be like, "You shouldn't do like this. If you do like this," even he will speak in Tamil lah. Of course, it's a Tamil class. What? You shouldn't do like this. If you do like this, you will get red mark. Be careful. So, in fact, you know what? I don't even remember his real name. I remember only him. I remember him only as the be careful teacher. Every time, every time his sentence, he must have a warning to say. Anything that comes out of his mouth has a warning intonation to it. Be careful. So we name him Be Careful. I think that was like what? 18, wait, I'm 43. 30 years ago, no. 25 years ago. 25 years ago. So, but then, yeah, the school is like one of the most fun. So that is when I will be texting my friends. Hey, you remember, be careful, today's Tamil paper, you remember this be careful teacher. He's like, then we will be like, reliving all our school days, right? So you will come to that. You will come to that and you will know what I'm talking about. All right, it's a beautiful experience. And every time I say at SPM itu, when I see each time I see the SPM paper, I will be like, wow, I remember this teacher, Mr. Chong. I remember, but mostly in the 90s. What am I talking? I'm 70s born. 80s and 90s, those were my schooling days. Mostly all the teachers, their standard face. That is their standard face. Or they have a neutral face. Saya tak ada perasan. It's very hard to see. Very hard to see. It's like a stigma that comes with the teaching profession, It's as if like when you go to teachings, when you go to a teaching school, I mean that it's like that is the first thing that they teach you. Please make sure your face is always turned. Actually, they don't. I don't know, for some reason, when you become a teacher, automatically your face just change. So I thought, okay, I'm going to become like that. All right. So we will keep on smiling all the time. Right. No. Yeah, the teachers are good, but it's always nice to get information from a smiling face compared to right. Oh my God, what am I doing? I'm just crazy. Forgive me, guys. I'm just so excited. Yeah, okay. So I think we can also finish this. We still have some time. Okay. So let's see the health of human respiratory system. Guys. All right. So this is again and again we have to emphasize. All right. So you must be thinking, yeah, teacher, nothing else to talk about. Why always want to talk about smoking? Because guys, you may pick up this habit along the way. And we don't want you to do that. We don't want you to do and get succumbed into this habit. So that is why since your scholar renda, since your primary school, we are reminding you at each stage, please don't smoke. Please don't smoke. Don't even start. All right? Don't even start. All right? Because it burns a hole not only in your lungs, not only into your health, but it also burns a hole in your pocket. Do you know how expensive is that? Your cigarette. All right. If you have any relatives, your dad or anybody, any close relatives who smokes, you go and ask. You know what? This is my observation. Honestly, mostly people who smoke, mostly, usually they are financially not well off. Yeah. That either unless it's a leisure smoking. All right. Because why, guys, each day you have to spend like nearly 20-30 ringgit just for the smoking. If you are making a lot of money, that's a different matter. But if you are like, you don't make much money, so it's actually burns a hole in the pocket. So not only for the health reason, but also for the economic reason. And not only that, you are actually putting your family in jeopardy. All right, because we have something called as the active smoker and passive smoker. Active smoker is like when I directly smoke, I'm an active smoker. Passive smoker is when I smoke, my child doesn't smoke. When I blow out the smoke, he inhales it. So that is actually passive smoking. Both are equally bad. Both are equally bad. All right. So again, okay, I don't like to go into this type of stuff early in the morning, but guys, please don't even start. All right. It has except for the nicotine, which gives you the addictive part, which gives you the euphoric part. Otherwise, there's no more plus point about it. And you guys, I'm telling you, no girls are impressed by a smoking boy. No girls. It makes your breath so smelly. It makes your skin gray. It makes your lips dark. You just don't have the glow. No girls like. All right. So don't even start. Okay. So these are the stuffs that they contain. I don't even want to go in it. We look at that, so many, and nothing about it is good. It's like a cocktail of hazardous. Okay. It's a cocktail of hazardous things there. Huh. All right. And it's not bringing any benefit. Not in any way. So don't even start. All right. So that is why we keep on saying this again and again and again. Okay. There is a reason for it. So carbon monoxide. Yeah. Sulfur dioxide. Carbon monoxide carbon monoxide, you have to be very, very careful, Carbon monoxide. Okay. When you give your hemoglobin choice between carbon monoxide and oxygen, they prefer to bind with carbon monoxide. They prefer to bind with carbon monoxide. The reason, very, very simple. Because carbon monoxide is more attractive, right? And oxygen is not. But what the red blood cell forget here is when they bind with the carbon monoxide, the bond is irreversible. Once you bind with the carbon monoxide, you cannot get rid of the bond. Okay? So your red blood cells get damaged. You cannot use them anymore. Become obsolete. Tidak boleh, dilupuskan. So what will happen? Slowly your body will lack of oxygen. When they lack of oxygen, slowly some things will happen. Then you sleep. Next morning you wake up in the heaven. Yeah. All right. So don't play. But this is actually in a high concentration now. All right. But in a low concentration, but it still does the damage. It's a slow poison. Slow poison. All right. Okay. Sulfur dioxide, another acidic gas, which damages your alveolus like nobody's business. All right. Just damages it. All right. So that is why we say that do not even start. Don't even start. All right. So these are the stuffs which are like hazardous. Nitrogen dioxide, again, another very, very acidic gas. All right. Irritates, difficulty, asthma. All right, PT. Nowadays, you can see a lot of problems. Why there are so much of problems in the world? This is the reason, right? We have so much of things in the air now. All right. Haze. This used to be yearly occurrence in Malaysia when Indonesia burns their, you know. But unfortunately, this year, due to the COVID issue, I think nobody went to work, I guess. But we still had haze a few days. I think they discreetly burned them. All right. So this can create, you see, maybe this one I don't even have to explain. You all have experienced it. All right, like sulfur dioxide, nitrogen dioxide, and carbon monoxide. Of course, you can't see, but your haze and dust you can see, and you have experienced it. And you have experienced closure of school. I don't know when you, but we experienced nearly a week of school closure due to terrible haze. Few years ago, I don't know which year was that, like 2006, we had it once really bad. Then we had it once again somewhere in 2013 or 14, like that. I don't remember the year. Quite bad until the school has to be closed for a week or so. But nothing is as bad as COVID. Schools are closed for nearly a year. All right. But we are through. Okay, we are through. Okay. Things are going to change for the better. All right. Okay, guys. So today up to here only. Okay, I'm not going to assign you any homework this week. All right, because I have not finished it. Actually, I have to go more into it. All right. But the next class, why is it gone? All right, never mind. Okay, I'm back. All right, guys. Okay, so that's all for today. I hope you have put in the attendance. Guys, please make sure you put in the attendance because these are the names that I'm going to put in the attendance for the school. So if you don't give me your name, then I don't put there. Then don't blame me. Teacher, I came and then my name is not there because you didn't fill up the attendance form. Right? Okay. Man, I look tired. Lot of work. All right. Okay, guys. I'll see you next week. It will be our last class before the holiday, before I see you back in school, I guess. Yeah. So I will try to finish this chapter for you. All right. Before we come back to school. All right. Okay, guys. I have to go to another class at 8:30. All right, guys. See you. Have a fantastic weekend. And I miss you guys. Hoping to see you. All right. Okay. Bye-bye. Bye, guys.